This is Advanced Math, Unit 10, Lesson 8. Limit as x approaches plus or minus infinity. Okay, so that's what our lesson is on today. Limit as x approaches positive infinity or negative infinity. We're not going to have them both at the same time, but it'll be positive infinity, or other times it'll be negative infinity, but they work out exactly the same way. Okay, number 1, the limit as x approaches infinity of the function 1 over x. Now, I'm going to explain this one graphically, only because it makes sense graphically, and the rest I'm not going to do so. But you've graphed this, I believe you did these last year in Math 3, where it looks like this. Now, if that was 0 instead of infinity, we would say does not exist, because at 0, this one goes up to positive infinity, and this one goes down to negative infinity. So if this had been 0, we would say the limit does not exist. We had that exact one in our notes the other day. Okay, but when it's approaching infinity, what ends up happening? So here's, this is positive infinity. So off to positive infinity, what is the graph getting closer and closer and closer to what y value? It's getting smaller and smaller and smaller and smaller. It never touches the x-axis. We've talked about that before, or you have in other classes. But it gets really, 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 really close. So what y value is it getting close to? It's getting close to 0. And even if that had been a negative infinity, on the negative infinity side, it's doing the same thing. It's getting really, 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 really close to 0. So the limit as x approaches infinity of the function 1 over x is 0. Okay? It never hits 0, but it gets really close, so we say the limit is 0. 0 is your answer. Now, think of plugging it in. Actually, we'll do that on the next one. Number 2, the limit as x approaches infinity of 100 divided by x squared. And I'm going to ask that you give me a second. Sorry about that. Okay, so the limit as x approaches infinity of 100 over x squared. Think of us plugging it in. 100 over infinity squared is 100 over infinity. Infinity squared is still infinity. If you had $100, $100 is a good amount of money, but if you divided it amongst an infinite amount of people, not a million people, not even a billion people, over an infinite amount of people, you're going to end up with pretty much nothing, right? I mean, if you divide it over and over and over and over amongst an infinite amount of people, you're going to end up with nothing, which is the same thing as this one here. 1 over infinity, if you think of it that way, you have $1 and you divide it amongst an infinite amount of people, it's going to equal 0. All right, so what we should think of right now is any number divided by infinity equals 0. It doesn't matter if your top number is 100 or 200 or 1,000. If you're dividing it by infinity, it's going to equal 0. Okay, so let's try another one. Number 3. The limit as x approaches infinity of 2x plus 5 over 6 minus x. Okay, this one's a little different from the other ones. So what you're going to do when you get to these type of problems, and you would even do it up here and it's going to work out the same, you're going to end up, let me write it down, you will, the steps, the rules are going to be, you will divide everything by the highest power of x, then take the limit. All right, so what that means by the highest power of x is top and bottom. You look at the whole fraction, numerator and denominator, and you look for your largest degree. Okay, at the top the degree is 1, at the bottom the degree is 1, so they ended up being equal. I'm going to divide everything by x. If that had been a 2x squared, I would divide everything by x squared, and we'll see that one in just a little bit. So for now, we get 2x plus 5, and we're going to divide both of those guys by x. Why x? Because it's the highest power of x, x to the first. All right, over 6 over blank minus x over blank, and I'll divide both of those by x. So, can you see the 2x plus 5 at the top and the 6 minus x at the bottom? And we divide everything by x. Reduces, leaving me with 2, plus that does not reduce, stays 5 over x. That does not reduce, 6 over x minus 1. All right, now I'm going to take the limit as x approaches infinity. And again, it doesn't matter whether it's positive infinity or negative infinity, we all do it the same way. Okay, so the infinity does not affect the 2 because it has no variable. Plus 5 over infinity, any number divided by infinity is 0. So 5 over infinity is 0. 6 over infinity is 0 minus 1. 2 over negative 1. My final answer is negative 2. So if we were to graph this function, the limit as x approaches infinity would be negative 2. Okay, let's try another one. Number 4, the limit as x approaches negative infinity of the function x over x squared plus 5. Okay, so this one we're going to do the same way we did here. We divide everything by the highest power of x. Okay, so the highest power, the degree at the top is 1, degree at the bottom is 2, so we're going to divide everything by x squared. So I divide the top x by x squared, that by x squared, and that one by x squared. Everything gets divided by x squared because that is the largest power of x. Okay, that reduces to 1 over x. 1 plus 5 over x squared. That reduced. This is 1, and this here, nothing reduces. So when you do this, you're going to now take the limit as x approaches negative infinity. And again, it doesn't matter whether it's positive or negative, you treat it the same way. 1 over infinity or 1 over negative infinity is going to be 0 over 1 plus 5 over infinity squared is still infinity. 5 over infinity is 0. So I end up with 0 over 1, which equals 0. All right, let's try another one. Number 5. The limit as x approaches negative infinity of the function 5x squared minus 4 over 2x squared plus x plus 5. All right, so I take everything and divide it by the highest power of x. The degree at the top is 2, degree at the bottom of 2. So I'm dividing everything by x squared. And you never divide by like 5x squared or 2x squared, just an x or an x squared or an x cubed, depending on what the largest exponent is. And since the largest exponent, top and bottom, is x squared, I divide everything by x squared. Okay, that's going to reduce, leaving behind a 5, minus nothing reduces, 4 over x squared. That reduces, leaving behind 2, plus only part of that reduces, 1 over x, and then plus nothing reduces here, so it's 5 over x squared. Okay, take the limit as x approaches infinity, negative infinity, same thing. 5 will not be impacted because there's no x, so as x approaches infinity, or negative infinity for 5, it's always going to be 5, it's constant. 4 over infinity is 0. 2 is another constant, it's always 2 no matter what x is, whether it's infinity or negative infinity, it's going to stay 2. 1 over infinity is 0. 5 over infinity squared is just 5 over infinity, which is still 0. 5 over 2 doesn't reduce. That is your final answer. Next one, limit as x approaches infinity of 3x squared over 3x. Okay. We take and we divide everything by x or x squared. X squared. So 3x squared over 3x over, and I'm going to divide them both by an x squared. And reduce, that reduces completely, so I'm left with just 3 over, only part of this one reduces, so it's 3 over x. Then I take the limit as x approaches infinity. The constant 3 at the top is going to stay 3, divided by 3 over infinity is 0, and 3 over 0 is undefined, so we say the limit does not exist. D and E. The limit does not exist. Why does it not exist? Because this comes out to be undefined. Undefined isn't your answer. Your answer is D and E, because they're asking what is the limit. The limit as x approaches infinity doesn't exist. It's going in opposite directions or whatever may be happening. Okay, let's try one more. 7, the limit as x approaches negative infinity, x cubed plus 7x squared plus x minus 5 over 2x squared plus 1. We're going to take this and divide everything by x, x squared, or x cubed. That's the largest one, top and bottom. So I'm going to divide everything by x cubed. Everything in the numerator, divide it by x cubed. And then everything in the denominator, divided by the x cubed. All right, that reduces to 1, plus that reduces to 7 over x, then plus 1 over x squared, minus 5 over x cubed. You guys see how that did not reduce? That one set did, 2 sets did, everything did, so you're left with 1. All over, let's see, that becomes 2 over x plus 1 over x cubed. That reduced there. The x squared's gone, x cubed became x. All right, so limit as x approaches negative infinity does not, it never impacts a constant. The constant's going to stay 1. Plus 7 over infinity is 0. Plus 1 over infinity is 0. 5 over infinity is still 0. Even though it's cubed, infinity cubed is still infinity. 2 over infinity is 0. Plus 1 over infinity is 0, which gives me 1 over 0, which is undefined, which means the limit does not exist. And that is it for this lesson.